All right, everyone, looking at my clock now, I am seeing it is now 5 o'clock, so we're going to go ahead and begin with our program. For those of you who don't know me, my name is Andrew. I am one of the planetarium educators over at the Liberty Science Center in Jersey City, New Jersey, and I'm very excited to be here with you today, talking about some of the things that you can find in your night sky during the month of December. We'll be talking about the planets Jupiter and Saturn and the best ways to find those in the sky in particular. Now, a few housekeeping things before we do begin. For those of you who are not familiar with Liberty Science Center, we are a nonprofit science center based in Jersey City, New Jersey. And if you want to come by and check us out, now is a really, really great time to do that. Because now through January 3rd, we are running some special holiday programming, both in the planetarium and throughout the rest of the Science Center. For more details on special experiences we'll be having, as well as which dates in particular will be open, you can check out our website, lsc.org, and our Facebook page here for any updates on that. There's a few other things that I wanted to mention. I wrote them down because I always forget these things, unfortunately. As I mentioned earlier, our next Planetarium Online show will be next month, January the 7th. We will be talking all about some exciting astronomy events to look for during 2021. So that'll be happening January 7th at 5 p.m. At the same time you are tuning in to this now. Also, if you want to support Liberty Science Center and these planetarium online streams, the best way to do that is by using the donate button, which is visible somewhere around my head, depending on which platform you are viewing this on. That's the best way if you'd like to, and if you're able to support Liberty Science Center and our mission to bring science to everyone and to inspire the next generation of scientists and engineers. So today we'll be talking about the night sky, Jupiter, Saturn, and now's actually a really good time to talk about this. Because by the time we wrap up our program today, at least for those of us here on the East Coast anyway, it'll be starting to get nice and dark outside. So when we finish our program today, you can step right outside and find the same things that we're going to be talking about today. And of course, if you have any questions during the program today, you can write those in the comments section. I'll be keeping my eye on that during the program today. We'll answer as many of them as I can. And my colleague Krista is in the is in there as well in the comment section. She'll be typing out answers to some of your questions as well. With all of our housekeeping out of the way, we can go ahead now and begin with our show by stepping outside, seeing the sky that we'd be able to find, well, right now. If we were to peek outside, if it's not cloudy, looking out my window, it's a little cloudy here, right after 5 o'clock, this is what you can see in the sky. Now, I want to mention that everything we'll be seeing today will be from the perspective of New Jersey, because that's where Liberty Science Center is. But if you are anywhere in the northern hemisphere, especially if you are around the same latitude as New Jersey, you'll be able to see the exact same things in the sky. So, so even though we're looking at this from New Jersey, as long as you're in the northern hemisphere, you'll be able to see pretty much the exact same stuff in the sky. But to see a little bit more in the sky, right now at a little after 5 o'clock, there's really only a couple things we can see, right? We can see a couple bright dots of light just starting to pop out. To see a little bit more, let's go ahead and fast forward through time. We're going to force the sun to go all the way down until about 6 o'clock this evening. So this is right when our planetarium online will be wrapping up today. So 6 o'clock p.m., this is what you'll be able to see. And if you're facing toward the southwest, right by where the sun just went down, well, you'll be greeted with two extremely bright things you can see in the sky. And it does not matter where you live, right? If you live in New York City or on a mountain in the middle of nowhere, you'll be able to see these two bright dots of light without much trouble at all. They're sitting kind of low in the sky now over here toward the southwest. So we can see the brightest of the two right here, and then a little bit fainter, still nice and bright, a little bit up above it. And both of these things right here are the two planets that we'll be sort of focusing on a little bit today, Jupiter and Saturn. So Jupiter is bright, Saturn is bright, but not quite as bright as Jupiter. And I want you to spend a moment thinking about why that might be, right? Why might it be that Jupiter is brighter than Saturn? Because the planets are about the same size. Jupiter is just a little bit bigger than Saturn, but not by much. The planets are about the same size. But the reason why Jupiter looks brighter is because it's closer to us. Saturn is almost 1 billion miles away from us right now, whereas Jupiter is only a few 100 million miles away. So Jupiter is closer, it looks brighter to us than Saturn does. Now let's talk a little bit about both of these two planets. They're a couple beautiful places to check out. Now, Jupiter, even though it's around the same size as Saturn, Jupiter is still the largest planet in the solar system. We're seeing a little animation here of us taking Jupiter apart and lining up a bunch of little teeny tiny planet Earths inside of it. We could actually line up 11 entire Earths across the inside of Jupiter. That's how big this planet is. Which means we could fit over 1,000 Earths inside of the whole great big volume of Jupiter. But as I mentioned a moment ago, Jupiter, even though it's closer to us than Saturn, is still really far away. So it's not a place that humans have ever been to. It's not a place that humans have explored directly because it takes 5 years to get there, traveling in a rocket. So we don't use humans to explore and study Jupiter. Instead, what we do is we build little robots, and we send those robots out into space instead, because, well, then we don't need to risk any humans to make a pretty dangerous journey all the way to Jupiter. And around 4 years ago, a new spacecraft made its way to Jupiter. A spacecraft is named Juno. It's one of the coolest things that we've ever built. It flies super close to Jupiter. We're talking just a few 100 miles above the cloud tops of Jupiter, before spending most of its life pretty far away. Most of its life is spent way out here, right? Hundreds of millions, or at least tens of millions of miles away, because Jupiter is a dangerous planet, a lot of radiation. Every 53 days, Juno gets nice and close, close enough to help us really explore Jupiter, helping us to explore its weather, its storms, and in its 4 years so far, Juno's helped us better understand these weird sort of Jupiter hailstones. They're a weird mix of water and ammonia ice that are called mush balls that form in sort of the lower and get brought up into the upper atmosphere of Jupiter. So Juno's been a really great tool, but it's not the only one that we use to study Jupiter, right? We can still see Jupiter from the Earth or from space using some of our telescopes. This here is the most recent, like, full disk picture of Jupiter that we have in a ton of detail. This picture was taken this past September or August, somewhere around there. And it shows us in great detail some of what's been happening on Jupiter recently. In this picture, we can see the enormous Great Red Spot right here. This storm is bigger than the Earth. It's over 400 years old. But it's not the only storm that we find on Jupiter. We find a few other smaller storms forming around here, and one storm a little bit beneath the Great Red Spot that's beginning to almost get as big as the Great Red Spot. It's not quite there yet, but who knows? Maybe it will get there. So Jupiter is a place that we really are just beginning to understand how it all works, and Juno is a big reason for that, right? Juno is a great tool to help us understand Jupiter a little bit better. So finding Jupiter is really easy. In fact, if you have a clear horizon right now toward the southwest, you can probably see it right now, if it's getting a little bit dark outside for you. So just up and to the left of the planet Jupiter, tonight we are going to find the planet Saturn. And just like we use Juno right now to study Jupiter, for about 13 years, we used another spacecraft to help us study and explore Saturn. Right, the spacecraft that we used to study Saturn was named Cassini. It looked a little bit something like this. It flew all the way to Saturn and spent 13 years better exploring that planet. And like Juno, it took a kind of a similar path, right? It took these very long elliptical sort of oval-shaped orbits. And we can actually see everywhere that Cassini traveled during its 13-year mission. It had a pretty incredible journey. So we'll trace out its entire path here that Cassini took on its 13 years of helping us better understand Saturn. For its first 4 years, it sort of flew all over the place, which we see in blue. The next 2 years we see in green. The next 7 years we see drawn here in yellow. And the last sort of grand finale of the Cassini mission, which was back in 2017, we see drawn here in red. I love looking at this picture because it shows just how much of Saturn that Cassini spacecraft helped us explore. And if you look very closely here at the path it took in its last few months, this red here, it actually flew between Saturn and its rings, right? There's actually a little gap between the main body of Saturn and its rings. And Cassini actually flew through that gap several times before its fuel eventually completely ran out and it ended up sort of crashing itself into the atmosphere of Saturn. Cassini helped us learn a lot about Saturn, though. It was a really great spacecraft. But it really, I mean, when you think of Saturn, right? When I think of Saturn anyway, I think of Saturn's rings. That's the sort of the first thing that pops into my head. We can see here the rings of Saturn are giant. We can see a little model of the Earth, a model of the moon put up, not quite to scale. This moon's a little bit bigger than our real moon is. But the rings of Saturn would stretch almost all the way from the Earth to the moon if we could plop them down right in between us. And we hear about the rings of Saturn more than the rings of other planets like Jupiter, Uranus, Neptune, because the rings of Saturn are easy to see compared to those anyway. That's because of what they're made of. The rings of Saturn are made of lots and lots of small pieces of ice, a little bit of rock, a little bit of dust and dirt mixed in here as well. And the ice in these rings are great at reflecting light back to the Earth, acting like a kind of like a big mirror almost. And these rings formed just maybe 100, 200 million years ago when Saturn actually ripped to pieces one of its big icy moons. So Saturn's gravity ripped the moon that was here into pieces, and now we see the rings of Saturn as they are here. We still find other moons in the rings, right? This is a moon named Pan, which clears out this gap through the rings. But that's far from all of the moons that Saturn has. Saturn has more moons than any planet in the solar system. It's got 82 moons, a ridiculous number. And one of the more interesting moons of Saturn is a little icy moon named Enceladus. This was a moon that was studied a lot by Cassini. It's a really great moon to explore. The outside is icy, but what Cassini helped us understand is that beneath this outer shell of ice, which is a couple miles thick, beneath that sheet of ice, there's actually a huge liquid water ocean. That's right, there is an ocean here inside of this moon, which is pretty cool. We are extremely sure about that, because down here on the South Pole, where we're sort of replicating where Cassini flew right now, we've actually found evidence of geysers spewing out chunks of water and ice. Looking at old data from Cassini a few months ago, astronomers also discovered that very recently the northern half of Enceladus was also pretty active and pretty busy as well. So we'll talk a little bit later about us looking for life in the solar system. And we know that on the Earth anyway, life needs water. And right here on a moon, well, we found water, right? We found water inside of a moon and inside of Enceladus, orbiting here around the beautiful planet Saturn. So as we get a beautiful look here at Saturn, I'm going to take a quick moment here, look and see if we have any questions that we can answer before we move on to looking and so we can look and see how these planets will move in the sky. Yeah, so I am I'm seeing a few of us mentioned that yes, indeed, the rings of Saturn are made up mostly of ice. There's a little bit of rock, some dust, some dirt mixed in there as well. So, but it's mostly ice, and that's why those rings look so shiny and bright as we view them from here on the Earth. So I'm not seeing. So I'm seeing a question. So why does Saturn have stripes? So why does Saturn have stripes? We also kind of saw that with Jupiter, that Jupiter also had stripes. That all comes down to some of the wind and some of the weather patterns and just sort of and just sort of the gas and the temperature of gas that we find here on Saturn. Same thing on Jupiter. So different, just little differences in the composition of gas make it look like a different color. Part of the striping that we're seeing down here, actually, these are actually shadows coming from the rings of Saturn. Those are these sort of dark stripes down here. These are actually shadows coming from the rings. So those are the easiest stripes for us to see. So Lauren wanted to know, how do we know that there was a moon here that was ripped apart? It's a really, really great question. And I guess I should say we don't know for sure that's where the rings came from. Um, that's just, we think, the most likely formation of those rings. So we think it used to be a moon by measuring how much material there is there and by measuring how quickly those little pieces are traveling around Saturn. If these rings were much thinner, we would think, or if they weren't as wide, excuse me, we would think that maybe the rings were formed by an asteroid or a couple of asteroids. But because of how much stuff there is here, we're pretty sure that it used to be from a moon. Again, we're not 100% sure, right? We don't have a time machine to go back and watch it happen, but we're pretty sure just by looking at how much stuff there is here. We can also measure the composition of it, sort of what the different bands of rings are made of, what chemicals they're made of, and they're all made of, they have a very similar chemical composition, which makes us think that they all used to be part of the same big thing. Let's see. So the names of some of the other moons of Saturn, there are 82 of them. So I do not know all the names of the moons, because my memory isn't quite that impressive. But the largest moon that Saturn has is named Titan. Some of its other bigger moons, Mimas, for example, is a really, really interesting moon that we find here around Saturn. And yes, there are absolutely other moons here, right? There are 82 moons that orbit around Saturn. 82, more than any planet in the solar system. Though I should mention, I just read a paper a couple weeks ago where some scientists found evidence that Jupiter may have as many as 500 moons. We haven't confirmed those moons quite yet, so we can't say for sure if it has that many, but it could be possible that Jupiter has has like 500 moons, right? We don't know for sure, but a few scientists think it's definitely possible. So for now, let's go back here into our evening sky. If you got more Jupiter, Saturn questions, Krista can answer some more of them, and then we'll be able to answer more of them at the end of our program today as well. So part of the reason why we're sort of focusing our time today on Jupiter and Saturn is that soon, very soon anyway, they will be leaving the sky for at least a few months. If you've been following along with our planetarium online streams since we started in April, the first show we did, right, was talking about Jupiter and Saturn, where to find them in the morning sky. They've been visible every night since then, and toward the end of December, the beginning of January, they'll be gone from the sky again. So if we sort of get our view a little bit closer here to Jupiter and Saturn, we can watch how they're going to be moving throughout the sky every single night between now and the end of this year. So we see Jupiter here, the bright dot, Saturn a little bit fainter. As our time goes by, look at the 7th, the 8th, the 9th of December, we notice Jupiter and Saturn getting closer to each other and closer to each other. The moon makes an appearance here in the southwest sky on the 17th and the 18th. And then on the 21st, something really interesting happens. They get extremely, extremely close together. Jupiter and Saturn look like they're almost on top of each other. Now, you might hear in the news, you might hear this called a conjunction, which it is. A conjunction is just a word that we use that essentially means two things have gotten really, really close to each other in the sky. And on December 21st, these two planets, Jupiter and Saturn, are going to be extremely close together. This is the closest conjunction of them in about 400 years. So this is a really, really cool thing that doesn't happen all the time. So Jupiter and Saturn are going to look very, very close to each other in the sky. And in fact, if you had a telescope that was pointed up at Jupiter and Saturn, this is what you would see if you could keep it pointed there for a pretty long time. Jupiter and Saturn will get so close to each other that they'll be visible in the same telescope eyepiece. So if you have a telescope, that is going to be a wonderful time to pull out your telescope and see them at the same time in the same eyepiece. This only happens roughly every 20 years. This is a super rare event. And at their closest, they'll be just 1/10 of a degree apart from each other. Extremely close, just 1/10 of a degree apart from each other. To give you a sense of just how close that is, if you have a dime, like I've got one here, and you hold out that dime at arm's length, right? How big that dime looks to you, that's going to be the distance between Jupiter and Saturn on the 21st. Super, super close together. Now, they're not going to quite look like just one point of light in the sky. They will at first glance, but if you look at them very closely, you'll notice that they are two different points of light. So this conjunction will be happening on the 21st of December. I am so excited to check it out. But then as time goes by, after the 21st, what we'll notice is the two planets are going to get further apart from each other again. So they're only going to really be like stacked on top of each other just the evening of the 21st. So if you want to see that, I have some great advice for you. Go outside just as the sun is going down on the 21st. That'll be about 4:30 to 5 o'clock Eastern time will be your best way to step outside and see Jupiter and Saturn in their conjunction. They'll be extremely low in the sky toward the southwest. So make sure that you don't have many buildings or trees blocking your horizon. So on the 21st of December, look toward the southwest just as the sun goes down. They'll be visible from about 4:30 until about 7 o'clock in the evening on the 21st. So pretty small window of time. So if you have time to check it out, I could not be more excited. I'll be watching it certainly, and I hope that you will be too. But unfortunately, as time goes by after the 21st, Jupiter and Saturn are going to sort of split apart. Well, once again, what we'll notice is Saturn looks like it's kind of overtaking Jupiter in the sky. They'll continue to get further and further apart from each other. And by the beginning of January, by the new year, they will be so low in the sky that they'll be pretty much impossible to see. They'll still technically be visible through January 3rd and 4th, but if you want to see Jupiter and Saturn, do it soon. Do it soon, because the next time they'll be visible in the evening sky will be several months from now. So Jupiter and Saturn, your best chance to see them for a while is, well, tonight. And then the next best chance will be the next night, up until they get too low in the sky to see in late December and early January. So I get questions a lot around when conjunctions like this happen, about why they happen once every 20 years, and it looks like they're close together, but are Jupiter and Saturn actually going to sort of crash into each other? So let's talk for just a second here about why we can see certain planets in the sky and why this conjunction will be happening. So we're looking actually now at sort of a top-down view of the solar system. We've got the sun here at the center, Earth, Jupiter, and Saturn. And pay attention to the date we're looking at. This is actually from 2 years ago. This is December 3rd, 2 years ago. This is what the solar system was sort of set up like. So when we can see planets entirely depends on just where they happen to be in their orbits around the sun. Because remember, all the time, the Earth is orbiting the sun. Jupiter is orbiting the sun. Saturn is orbiting the sun. All the planets are constantly traveling in their orbits around the sun. And we can see planets in the night sky when our view from the Earth to them is not blocked by the sun. So on the 3rd of December 2018, 2 years ago, Jupiter we couldn't see in the sky because the sun was in the way. The same deal with Saturn. So we can actually sort of draw out some lines to sort of mark out what our view line is between the Earth and Jupiter and the Earth and Saturn. Let's move forward through time here. So between 2 years ago and today, Jupiter, Saturn, and the Earth have continued in their motions around the sun. They've moved in such a way that tonight, Jupiter and Saturn are both visible, and our view lines of them almost overlap tonight. And the reason why the conjunction of these planets will be happening on the 21st is because on that date, our view line between the Earth and Jupiter and between the Earth and Saturn will be almost exactly lined up, right? You can think of it if you put like two hands in front of your face, for example. One of them comes around, and then you would see both your hands close to each other, right? Because they've just sort of gotten that way in their pretend orbit around your head. So these happen every 20 years because the orbits of Jupiter and Saturn are really, really slow. They're really slow compared to the Earth. It only takes the Earth 1 year to go around the sun. It takes Jupiter and Saturn a longer time to go around the sun. So I hope that this sort of puts a little bit of an explanation behind why this conjunction is happening in the first place. It's because they're lining up in their orbits to the point where it looks like they're on top of each other. But as you can see here, they're still extremely far apart from each other, right? Jupiter and Saturn aren't going to crash into each other. That's not going to happen. They're still hundreds of millions of miles apart from each other. They just look like they're close to each other in the sky. So again, December 21st, the conjunction of Jupiter and Saturn. I am so excited, and I hope that you have a chance to see it. I hope it's not cloudy. Hope we have some nice clear skies all over the world for this extremely rare event, right? This is the closest conjunction in 400 years of Jupiter and Saturn. I couldn't be more excited. And this should be visible from anywhere you are, as long as you are away, or as long as you have sort of a clear horizon, right? If you live in the middle of New York City, right, you can find a place with a clear view. You can find them. Jupiter and Saturn are bright enough to be seen no matter what your light pollution is like around you. So if you're in a city or in the middle of the mountains, you'll be able to see Jupiter and Saturn, as long as you can find a clear view of the southwestern sky. That's going to be the sort of the biggest issue, is finding a clear view of that part of the sky. Let's see. So let's check our chat here real quick, see what questions we can go ahead and answer. So Carol wanted to know, can we ever see Pluto? Unfortunately, we cannot ever see Pluto with our eyes. It's too far away. With a telescope, though, if you know exactly where to look, you can see it. But you do need a telescope to see Pluto. So we can't see it with our eyes. Just a little bit too far away. Let's see. Abby wants to know, are they in the southwest sky today, or is it more precisely west-southwest? So tonight, they are pretty much exactly southwest. Pretty much exactly southwest. On the 21st, they'll be a little bit further to the west. But tonight, they're pretty much exactly southwest. Great question, though. Let's see. And to answer another question, luckily, we don't need a telescope to see this conjunction. If you have one, pull it out. It'll look really cool in your telescope too, but this can be seen with just your eyes. If you've got a pair of binoculars as well, you can pull those out to check out this conjunction, but all you need to see the conjunction are your eyes and some luck with the weather. If it's too cloudy, we're out of luck. But if it's clear, with just your eyes, you can see this conjunction. If you can find a dime, right? See if you can fit it between the space of Jupiter and Saturn in the sky. Fun interactive activity to try. Let's see. So how many miles is it from Earth to Saturn? I don't know the exact number off the top of my head, but it's somewhere around 1 billion miles. It's like 950 million miles. So we'll round it up to just say about 1 billion, right? I like to round numbers because I'm bad at remembering exact numbers, unfortunately. So Amy, to answer your question, so does this occur every 20 years, but can only see it every 400 years? That's a great question. So a conjunction happens every 20 years, but this one is just happens to be a little bit closer than they normally are. So we can't always see every conjunction, though. The one 400 years ago was really hard to see because they were a little bit too low in the sky. So this is a great one because they're really close together and they're high enough in the sky to be able to be seen. So there is a conjunction every 20 years, but we can't always see the conjunction because sometimes the sun gets in the way. Sometimes the sun is between us and Jupiter and Saturn. So this conjunction is a really cool one because we can actually see it, and it's going to be really close together. Esther, thank you. That number sounds familiar. 987 million miles to Saturn. That number sounds right to me. So, or about 1 billion, if you're like me and can't remember exact numbers. Let's see. All right. So, this is actually a really, really great question. How do we know that these two bright dots of light are planets and not stars? It's a good question, right? Because planets in the sky look a lot like stars do. But there's two things you can look for. When it comes to Jupiter, you'll know it's not a star because it's the brightest thing you see in the sky other than the moon. So that's how you can tell in this specific case. But another way you can tell is that planets don't twinkle in the sky, but stars do. So if you see a really, really bright thing in the sky and you notice it twinkling, it's a star. If it's not twinkling, it's a planet, right? So planets don't twinkle. That's another good way to tell them apart. But for tonight, you can tell a bright dot is Jupiter because it is the brightest thing in the sky right now. And I was actually reading a few of us mentioning that you're actually looking at Jupiter and Saturn right now, which is pretty cool. I can't see it because there's a big building in my way, but if you can see Jupiter and Saturn right now, that's pretty cool. All right. So JP wants to know, when Jupiter and Saturn are at their closest, how many miles apart will they be? That's a great question. So at their closest, they're around 400 million miles apart. Again, my memory, I don't know exact numbers, but somewhere around 400 million miles apart is when they're at their closest together. Somewhere around there, plus or minus 10 or 20 million miles. What I love about astronomy is that we don't usually get super precise with numbers. Helps me out quite a bit. All right, so that's Jupiter and Saturn, but I did want to give us, before we run short on our time, I wanted to give us a few other things that we can look for in our sky during the month of December, right? We're looking now toward the southwest. Jupiter and Saturn are going to be there shining nice and bright. If you turn your attention, though, toward the south right now and the southeast, you can see another planet, right? We can see a nice, bright, red orange point of light in the sky, way up high in the sky, way higher than Jupiter and Saturn, right? Way up here toward the south, a little bit toward the east part of our sky. And this just so happens to be my personal favorite planet in the solar system, Mars. And unlike Jupiter and Saturn, Mars will stay visible in the sky every night for about the next 6 months, 7 months. By June and July of next year, it'll be getting low in the sky. But any night between now and next summer, you'll be able to see Mars shining nice and bright in the sky. Also over in the eastern sky, we're getting into the winter season now. As it has been really cold here in New Jersey the past few days. We're just beginning to now see some of our wintertime constellations. So we're facing here toward the east, what this great big red E stands for, and just a little bit above the horizon, over in this part of the sky, we can see one of our winter constellations, and you can find it by looking for the shape of like a sideways V. Although I guess also looks like a greater than sign. Low in the sky, made up of 6 stars, pretty close together. 7 stars, even pretty close together. These stars make up sort of the head and the face of a constellation that looks kind of like a wishbone almost when we draw it out with its stick figure here. But this is a constellation you've probably heard of before. One of the constellations of the zodiac. This is Taurus the Bull. Now, Taurus is always the first constellation that I like to look for in the winter because it has a couple of really cool things inside of it. Up in the shoulder of Taurus, up here, we find a group of like 6 or 7 stars getting very, very close to each other. These 6 or 7 stars, depending on how dark your sky is, sometimes maybe you can only see 4. This is a group of stars called the Pleiades. These are 7 very hot, young stars. So when I mentioned that these stars are young, how old do you think I mean when I say that these are young stars? These are young stars. Now, Young for a person, right, is maybe 1, 2, 3 years old, right? That's pretty young for a person, like a baby person. But these are kind of like baby stars. But they're around 50 to 100 million years old. So stars live for a super long time. And these brightest stars here are around 50 to 100 million years old. And those are young for stars. These are just little, well, really big baby stars, but they're still pretty young. So that's the Pleiades. We can see that really anywhere you're at. Even if you're in a pretty light polluted sky, you can see the Pleiades, and you just need your eyes. That's all you need, right? That's all you need is your eyes. Now, looking toward sort of the eye of Taurus the Bull, we find a sort of reddish-orange colored star, right? We see his one eye over here, his second eye down here, marked by this reddish-orange star. This star is named Aldebaran. Aldebaran. It's a really bright reddish-orange star that we can see out in the sky. But if you stay up a little bit later, right? Not even that late, right? We're going to move forward to about 8 o'clock in the evening tonight. You can begin to see another very famous constellation at 8 o'clock in the evening. The moon as well starts to pop out around 8 p.m. tonight. You can see another very famous constellation just coming up above the horizon toward the east. This group of stars right here, marked most brightly by the 3 stars here in the shape of a belt, sort of like a vertical line low in the sky tonight. This is the constellation of Orion the Hunter. Now, Orion is my favorite constellation to look for in the sky because it's usually pretty easy to find. All of the stars inside of Orion are super, super bright, right? All of these stars can be seen from pretty much anywhere, as long as you see a clear sky. But of all the stars in this constellation of Orion, my favorite star, I do play favorites. If you've been watching our Planetarium Online shows, you know I play favorites when it comes to things in space. And my favorite star in the entire night sky we find in this constellation. It's another reddish-orange star right here in the shoulder of Orion. This star, it's my favorite because it's got the most fun name to say. This star is named Beetlejuice, or Betelgeuse. I say Beetlejuice because it's fun to say. Now, Beetlejuice and Aldebaran are both red stars, so they're kind of similar to each other. And they're both stars that are quite a bit larger than our sun. So, to put up for just sort of a scale comparison here is a scale model of Aldebaran and a scale model of the sun. The sun is about 40 times smaller than Aldebaran, right? If we put the sun right next to Aldebaran, it would look pretty small. We call Aldebaran a red giant star. So Aldebaran is a red giant. The sun is sort of a yellow main sequence star, what we call the sun. But Beetlejuice, our good friend down here, doesn't look a whole lot brighter than Aldebaran. But Beetlejuice is way bigger than Aldebaran. Beetlejuice is one of the largest stars that we ever see in the sky. Beetlejuice is about 800 times bigger than the sun. I could not fit it on our screen here. That's how big Beetlejuice would be on this scale. Beetlejuice is 800 times larger than the sun. It is huge. One of the biggest stars we can ever see in the sky. But Aldebaran is what we call a supergiant. or sorry, is what we call a red giant. Beetlejuice is what we call a red supergiant. And you can probably guess how it got that name, right? Because it's, well, supergiant. We needed a name for something bigger than a giant, so supergiant. Astronomers aren't the most clever when it comes to naming things sometimes. So these are a couple of really bright red stars that we can see in the sky. But I always like to look for Aldebaran in the sky. It's one of my favorite stars to find because it is a great example of what our sun will look like in the very, very distant future. Aldebaran used to be about the same size as our sun. Used to be. But stars like the sun do not stay the same forever. They constantly change. And the sun, in about 5 billion years, again, 5 billion years, a super long time from now, is going to look a lot like Aldebaran will. So this is not something that we need to worry about, right? Because it's not going to happen for 5 billion years. 5 billion years, that's such a long time from now. But it will happen. And when it happens, this is what the sun will do. The sun eventually will begin to run out of its supply of hydrogen. That's what the sun is burning through right now. As time goes by, the sun will run out of its hydrogen. When this happens, it'll start to shrink. That'll make it get hotter, and that'll cause it sort of balloon up. Over the course of time, not very long time, it'll get bigger and swallow Mercury. It'll swallow Venus. And eventually, will most likely even swallow up our very own planet Earth. Now, I don't want you to worry about this. This is nothing to be worried about because this will not happen for another 5 billion years. It's nothing we need to worry about. By this point, humans will be able to travel to different stars and planets and be able to live there if we need to. After living as a red giant for about 100 million years or so, the sun will have completely run out of fuel it can use. The outer layers expand away into space. The center will sort of collapse down and form what we call a white dwarf. And this is the future of the sun, right? And we learn about this, right? We learn about this by studying other stars, like Aldebaran, right? So by looking around at the rest of space, we learn a lot about stuff like the sun. The sun's pretty important to us. So it's nice to learn more about how our sun works and how it'll change in the future. But now that we've seen the future of the sun, what'll happen to the sun in 5 billion years, we've seen Jupiter, Saturn, we've shown you the conjunction happening on December 21st, we've seen Mars. We're running a little short on our time here. I'm looking down, it's at about 5:45 now, so we're gonna go ahead now and begin to wrap up our program today. Now, if you've got questions that have gone unanswered so far, we apologize if we can't answer every question. There's been a lot of you asking them. I know Krista's doing her best right now. But if you've got more questions that we haven't answered, you can write them in the comments. I'll be answering questions for about the next 10 minutes. So if you've got more questions, you can write them now and we'll do our best to answer as many as we can. But while we're waiting for questions to come in, I did just want to thank everyone for joining us today as we talk about the December sky, about Jupiter, and about Saturn. Now, if you want to come and check us out at Liberty Science Center, between now and January 3rd, we'll be running special holiday programming. Krista made a really, really great holiday-themed laser show that's playing in the planetarium right now. I saw it the other day. It's incredible. So you can come check that out. You can visit our website, lsc.org. Check out our Facebook page for more details on that. If you've enjoyed the program today and want to support us, support the planetarium and Liberty Science Center, if you're able to and you'd like to, you can support us by using the donate button, which is somewhere around me right now, depending on where you're watching this. It might be over here, might be above me, might be below me. I don't know where it's at. There should be a donate button on your screen somewhere that you can use to support us. We'll be live again with our next Planetarium online show, though, on January the 7th. We'll be talking about some cool astronomy events happening in the year ahead in 2021. But once again, thank you so much for joining us today. I'll be hanging out for about the next 10 minutes until 6 o'clock to answer more of your questions that we have about Jupiter, Saturn, the conjunction, about the sun, or really any questions that we might have. Okay, so I see a really great question. Nabanti wants to know, is there a star bigger than Beetlejuice? Yes, there are stars larger than Beetlejuice. The largest star we've confirmed is called UY Scuti. It is a really fun name to say. So UY Scuti, it's about twice as big as Beetlejuice. About. So stars do get bigger than Beetlejuice, but Beetlejuice is about the biggest star you can see with just your eyes. UY Scuti is a little bit too far away. Let's see. So Priya wanted to know, where is Beetlejuice? So let me bring up our sky here once again. So if you want to find Beetlejuice, you want to go outside in now around 8 o'clock in the sky tonight, right? As December goes into January, it'll be up a little earlier in the evening. But for now, around 8 o'clock in the evening. So look low in the sky toward the east for the constellation of Orion the Hunter. It's a really great constellation to find because it's really bright, right? This shape should really stand out in the sky. So you can use these three stars in this belt to help you out. And then Betelgeuse is the reddish-orange star over to the left of the belt. And I promise, Betelgeuse stands out really, really well, right? It's so if you want to ask your class to just look out in the eastern sky around 8 o'clock tonight, Betelgeuse will really, really stand out. But Orion is a really good tool to help you find it, right? But toward the east, around 8 o'clock tonight or later, Betelgeuse shines nice and bright. Whoops. Wrong button. Let's see. So, any questions? So, any more questions that we see here? So, how many Earths can fit into Betelgeuse? That's a good question. So, Betelgeuse is about 800 times the size of the Sun, and about 1,000,000 Earths would fit inside of the Sun. So I think, unless I'm messing up my math, about 800 million Earths would fit inside of Betelgeuse. I think I've done that math correctly. So about 800 million Earths could fit inside of Betelgeuse. It is gigantic. It is gigantic. So Nicole wants to know, is there any black hole bigger than the Sun? Yes. Yes, there most certainly is. So we can define bigger in two ways, right? We can define it by mass, so essentially how much stuff a black hole has. And every black hole is more massive than the Sun, right? Every black hole has more mass than our Sun does. It's just crammed really tightly together. But there are black holes that are bigger than the Sun in physical size, right? Some of these supermassive black holes that we find out in space, like the one at the center of our galaxy, is bigger in size than the Sun. So they do both get more massive than the Sun and physically bigger in size. But most black holes are smaller than the Sun, but are more massive. That makes sense. They're just very dense. So Maria wants to know, what will happen if Betelgeuse dies? So I've got really good news for anyone worried about Betelgeuse dying. First of all, it won't happen for at least another few 100,000 years. And when it happens, it will not affect us in any way at all. But it will look super cool when it happens. When Beetlejuice runs out of fuel, it will explode and get super bright. It'll be bright enough to probably be visible during the daytime. That's how bright it'll be. And over time, it'll slowly fade away and disappear from the sky. But it won't be dangerous to us, right? It's way too far away to be a danger to us at all. So when it does happen, which it will, it'll be really cool. And I hope I'm around to see it, because it will be pretty cool to see. It'll also turn into a black hole when it, or a neutron star when it runs out of fuel. Let's see. So yeah, let's go back into our night sky. So Liz wanted to know if Beetlejuice's position changes in the sky. So as the night goes by tonight, it will absolutely change in the sky. As time goes by tonight, it'll get higher and higher and higher in the sky. So it'll reach its highest point in the sky around midnight tonight, midnight 1 in the morning. And in fact, if you stay up really, really late, like wake up really early in the morning, Beetlejuice will actually be over in the west. Actually, we can't even see it anymore in our camera. Oh, there it is. So around 1 a.m., it'll be almost directly south. And then as time goes by, as we get toward the early morning sky, Beetlejuice will be over in the west. So if you want to have a really, really late night, you can actually track Orion's position going across the entire sky from the east all the way to the west. If you want to stay up really, really late, you can do that. And then the sun comes up and Beetlejuice is gone and Orion is gone from the sky. Around 7 a.m. it'll get way too bright to be able to see anymore. So Diana wants to know, is Saturn and Jupiter near the moon in the sky? Tonight, no. Tonight, Jupiter and Saturn are not super close to the moon in the sky. They're sort of on the other end of the sky. So Jupiter and Saturn are here in the southwest, and the moon, so here's Jupiter, Saturn. So here's Jupiter and Saturn in the southwest. The moon will be coming up over in the east. So if you find the moon in the sky tonight, Jupiter and Saturn will be over in the other part of the sky, right? So the moon doesn't even rise tonight until like 7 p.m. or so is when the moon is just beginning to rise. See the moon coming up here. But later in December, on the 16th, the 17th, the 18th, the moon will be close to Jupiter and Saturn. But not tonight, unfortunately. Ooh, Sarah asks a really good question. Can scientists tell if the stars we're looking at are still in existence? This is a really, really good question. Because light takes time to travel through space. I would say there is about a 99.9999% chance that every star we see in the sky is still living as we speak. There's an exceptionally good chance of that. But Beetlejuice is around 1,000 light years away from us. So when Beetlejuice dies, it'll take 1,000 years for us to know, because it'll take light 1,000 years to get from Beetlejuice to us. So I would say it's really likely that every star in the sky right now is still alive. There's a really, really small chance, like super small, that something happened to one of them. But I'd say, yeah, every star we see right now in the sky, it still exists. But what's cool is if we look at other galaxies, right? If we look at really distant galaxies from us, many of the stars that we see in distant galaxies are no longer alive. because it can take light from a galaxy 1 billion years or 10 billion years to get to us. So, a really interesting question. Really interesting question. Let's see. Any more questions that we can answer? Anytime you want to see Jupiter and Saturn in the next month, you want to go outside right as the sun goes down. So tonight, that's about, I mean, right now you can see it, about 5:30, 6 o'clock tomorrow, and the same thing every night until the end of this year. So right as the sun's going down, right as it's getting dark, will be the best will be the best time to look for Jupiter and Saturn. Let's see. So, see a couple questions about Saturn and what Saturn looks like when we go there. So let's wrap up our show today with one more final look at Saturn. So when we get really close to Saturn, this is what it looks like. No humans have been to Saturn. We've sent robots to Saturn, though. But we've never sent people here. But this is all what our robots that have explored Saturn have sent back to us. So this is what our robots see. So that's what we see too. And I saw a couple questions earlier about like an eyeball-shaped storm on Saturn. Or like an oval-shaped storm on Saturn. And there is one of those storms up sort of on the North Pole of Saturn, and another smaller one on the South Pole of Saturn. Those form just because Saturn has weather just like the Earth does, right? It's kind of the same reason that hurricanes happen on the Earth. Just sort of the way that pressures and temperatures in the atmosphere work out. All right, so with all of that being said, we are going to wrap up our program now. Thank you so much for all of your incredible questions and for joining us tonight. If you can look outside right now, everything we saw in the sky tonight during our show, you can see right now, if it's clear and it's dark where you are. So if it's getting dark outside where you are and it's clear, you can see Jupiter and Saturn right now. Pretty cool. You can see Taurus and Aldebaran and Mars as well. But yeah, our next Planetarium Online show will be on January the 7th at 5 p.m. We'll be talking about some cool stuff you can look forward to in 2021. Talking about some lunar eclipses, some partial, or at least one partial solar eclipse, the landing of the Perseverance rover, lots of cool stuff to look forward to in 2021. We'll be talking all about that on January 7th at 5 p.m. But thank you all so much. Have a wonderful, wonderful rest of your evening. And hopefully we can have some nice clear skies tonight to check out some planets and stars in the sky. Thank you all so much and take care.